So there you go. All right, I'm definitely gonna have to edit this one up on YouTube. It's Friday, man. Happy Friday, everybody. Plugged in. We got good sound. We don't got any lag. We don't have any spammers. Maybe this could be a good live stream to go down. It's number 41. It's Friday. So what I was talking about, today's topic, it's probably easier with sound, right? Today's topic is about, thank you so much for speaking up. I could have been sitting here forever talking. Today's topic is about tolerances and clearances. So I did a YouTube series called Absolute Beginner, and the question I've gotten the most is clearances on this lid. How do you define that inside of Fusion 360? So that is today's topic. Now, like I was saying when there was no sound, that we're probably going to call this one Volume 1, because I could definitely see that that this topic could kind of like grow longer than just, this half an hour that we're going to talk about today. So let's jump in and talk about tolerances and clearances. And if you are a CAD ninja and you've been doing CAD for years, or you are in manufacturing and you know all of these kind of things, do me a favor. Anything you have to add, put it down in the comment area of the video or in the live stream if you are live right now. Definitely just add on to all the knowledge. And don't forget, my email address is down in the description area. Send me any emails if there's any future topics you would like to see in the live stream. All right, guys. Let's get going. You should see Fusion 360 on your screen. Let's talk about Fusion 360. Let's talk about tolerances. All right, this is what we're going to do. I'm going to go in here and I'm going to open up a sketch. And I'm going to open a sketch here on the top here. Hit the S key and do a center rectangle here. And I'm just going to make this one 3 by 3. 3 by 3 inches. And let's extrude this thing out 6 inches. So what we got here is a rectangular block, 3 by 3 by 6. Now, just to make sure that my good friends who are outside the United States, let's just switch this one to millimeters for a second. And if we click down on a line in Fusion, I hope that you know that well, we can also measure it. Normally it shows up down here. This one here is 150 long, 150 millimeters. Well, I don't know why it doesn't. Maybe because I haven't saved it yet. By 76 or 75. So think about a block that is 75 by 75 by 150 long. And actually, just where we're in here, let's go into the body and right click, and let's go ahead and change the material to something we probably all could get a hand on. So I'm going to change to like pine, like Swedish pine, Russian pine, whatever. I'm going to switch the units back to inches for my own sake here. But here we got a block that is made a block out of pine, right? And in inches, it is 3 by 3 by 6, and in metric, it is about 75 by 75 by 150. So here's my question to you: if I asked you to make this block, if I said I would pay you a 6-pack, a case of beer to make this block, how would you make it? See, the thing is that the guy who really just wanna get the beer and start drinking, he's gonna show up with a chainsaw, and the guy who maybe is not so thirsty, he's gonna show up with a little file and be really accurate with this part. Now, if you're looking at the CAD model, that is perfect, right? Like Fusion goes down to like, 12 decimal places or something like that. So if we're measuring this, and this is measuring 3 inches, in the software, this is exactly 3 inches. But if you need to make this, well, what tools do you have available? Because we can all agree on that if I grab the chainsaw, it's definitely not going to be exactly 3 inches. It is going to be some variation within that. And that brings up another question is, how are we going to check this block afterwards? Like, so if I'm the customer, when you bring it back, how are we going to check this block? So that is one of the things we got to address when we're talking about tolerances. Now, when we're talking about clearances, so let's go in and turn this into kind of like put a cavity in here. Now here's a neat tool to do that, because I'm going to kind of try to introduce some new tools for you as we are going through here, because that's what I like to do. So let's go into the modify. Now if you have never seen the shell command, you absolutely going to love this. So I'm going to hit shell, and I'm going to select this surface here, and then I actually get to select a thickness, and I'm going to put in 0.25 and hit enter. And what I just did was I shelled out this entire body in here, and if I do a section view, so go into inspection, section analysis, and I click this face and I drag this arrow, you will see that I have 0.25 all along this edge. Really, really cool, right? So that is the shell command. Absolutely awesome to create things like this where you just want to hollow something out. You could, of course, also created a sketch, offset it in 2.5, extrude it down, but I mean, this is a lot easier. All right, now I actually want this to turn into an assembly because I'm going to create a lid for this thing. So I'm going to turn this into a component by right-clicking and say create component from bodies. So I'm going to click on that, and now you'll like to see that I get a component 1. Now I can go up and right-click and create a component 2, and that is going to be my lid. Now if you watched any of the other live streams, you know that going ahead and renaming these can be good practice. Just for later on. Okay, now this lid here, how am I going to create this lid? Well, again, there's different options to do this. Now, we are going to talk about tolerances and clearances here. So check this out. I'm going to go in and say, create a new sketch, and I'm going to select the top of this face here, and I'm actually just going to project the edges. So hit P for project, and I'm literally just going to project all the outside edges, all the inside edges, whoops, just like that, and hit OK. Now if I hide the box for a second, you will see that all I'm getting here is now kind of like that resembles of that I projected from the box. I'm going to hit Q, and I'm going to take the inside and I'm going to project that down minus 2.5. So that's going to go inside the box. Now I hit enter and my sketch disappeared. I can just go in and turn that back on again. That's a setting, by the way. Let me hit Q again for press pull, and let's kind of like make the other part of the box here. So we're going to make that also 2.5. I'm going to hide the sketch again, and let me turn the box back on. So now you can see that I now have the box, and we got a lid. Now let's also make the lid pine, just so we kind of like staying in the same kind of environment here. Going to the physical material. Now we have the pine up here. We don't have to find it down the drop down. We can just drag that on there. Close that. Okay, so what we have now is we have a box with a lid. Now I'm going to right click and use the move command. That was another one we used earlier, just to kind of like move this out of the way so we can talk a little bit about this. Now, right now when we're talking about clearances, we have absolutely no clearance between this surface and the inside. They are right on top of each other. And that, if you've ever tried to make something that should fit together, and and you make it the same size, it will not fit together. There needs to be a little bit of clearance in there for it to fit together. So that's one thing we got to talk about. Now, another thing we got to talk about is that if you, now this is made out of wood, so you might do a chisel or something, but if this was made out of steel specifically, you never will do sharp corners, internal sharp corners. Absolutely a pain in the neck to do. It's pain. We don't want to do that. So we're going to put some radiuses in there. So I'm going to add a fillet, and I'm just going to go ahead and add a fillet on all those inside corners. And remember, you don't have to turn your model around. You can actually select through there. 0.25. I'm keeping everything pretty simple. So now we got this inside radius here. Now, if I just go ahead to that move we did before and right click on it down here in the tree, I can actually suppress the feature. So I didn't delete it, I just suppressed it. Now we have kind of like our lid back together. Now somebody's going to say, well, wait a minute, we have an interference between the radiuses in the inside and the sharp corners on the lid. So there is actually another tool in here called interference under inspect. So if I click on interference, under inspect, interference, I'm going to select the top lid, I'm going to select the box, and then I'm just going to click compute right over here. And we get a little box here that shows us that that is where those interferences are, right? Because I rounded the inside of the inside of the box. Now I also got to do something with the corners. Okay, so I just wanted to show you that tool. Let me go back again and unsuppress the move command, so the lid is up again. Now, so we got to put something on these. Now, outside corners, we can put rounds on outside corners, but it's actually easier to use chamfers on outside corners. It's easier to make than round corners. So I'm going to go in here and add a chamfer instead. And I'm going to again select these outside corners here like that. And I'm going to make it a little bit bigger than the inside of before. So I like to make them 300. Hit OK. And I can do the same thing as I did before. I can unsuppress the feature here. And let's try again to do the interference, the lid, the box, compute, and now it tells us we have no interferences. I could also go in and do another section analysis, and we could click the bottom here, and if we scroll down, we should see down here that we have a nice clearance between the radius and the chamfer. All right. All good so far. So back to our question about tolerances and clearances. Because like I said, one guy's going to show up to the party with a chainsaw. One guy's going to show up to the party with a little needle file. And we need to kind of like establish what we really want on these models. Again, CAD models are perfect, right? Like if you're modeling something 3 inches by 3 inches, 12 decimal points, is 3 inches. Now in CAD, we normally model everything nominal, like I just did, where we didn't put in a clearance for the lid. And the reason we don't do that is because we got to define the tolerances anyways, and we do that normally in a 2D drawing. Now I keep on saying normally we do that because you can do whatever you want. I'm not telling you here what you need to do. I'm just telling you that in general, the CAD model is normal, so it's like literally 3 inches by 3 inches, and we don't add clearances normally. We do that on a 2D drawing. So let's go ahead and talk about 2D drawings a little bit. I'm going to save on the save icon. I have to do that before I can make it a 2D drawing. Just going to save this, whatever. Then we're going to go up to the model environment, and we're going to go down here to drawings and go in and say from design. So and I'm just going to create the standard here, bring in the whole assembly. So what I'm getting at is that normally when in manufacturing, you will have a 3D model that is nominal, and then you will have followed by this 2D drawing, and that will actually specify what the tolerances and the clearance are. So we get the view in here, and we haven't not covered drawings yet in the live stream, but it's another great topic we can do another day. I'm not going to follow completely and make this completely like up to standards, but that is fine with what I'm trying to prove here. You have a couple of different options. When you bring in here, we get kind of like a view, and I want kind of like an assembly view right in here. So I'm just going to place one box here for a kind of like an assemble view. And actually, you know what? I'm going to double click on it again, open up the box. I'm actually going to make it shaded because this is really just to resemble what the whole assembly looks like. I'm going to create a projected view from that up here. And again, this is not really a tutorial for drawings, but I'm going to create kind of like a third dimension view of this one here. So move that up, hit enter. So now I kind of like have a view, so if somebody looked at this drawing, they could kind of like see how this box kind of like go together. All right, now we're gonna break the box down to the two components we have, the box and the lid, and let's talk about all these tolerances. So I'm gonna go up and create a new base view, and that's gonna bring in the same thing you saw before. So I'm just gonna click and place that view, and I get that kind of like this tree over here. Now I can actually, when I hit OK here, I can actually turn off the lid. So this is now just the box. You can do that over here. I'm going to create a projected view of that drags up here. That will kind of like show us the top. Then I'm going to do another one of the lid. So kind of like repeat the same thing I did before. Select the box here. This time I'm going to turn the box off, so now I only get the lid, and I'm going to do a projected view of that one. Well, I actually wanted the other one here, so we can see the bottom end of it here. So what we really have right now is a drawing representation of this here. So move this down a little bit. All right, so this drawing is where we specify the dimensions of the part itself, right? So let's start with the box we created first. So the box was, let's add a dimension, 3 by 3, right? And then it was 6 inches tall. Everybody hopefully can agree to that. But here's the question. Like I said before, somebody's going to come to the party with a chainsaw. Somebody's going to come to the party with, you know, whatever they have handy. So what we do on these drawings is we're specifying how much this part can variate from the specific end result. So I can maybe go in here on this first one here and double click on it, and this little window will open up over here. By the way, it shows us how many decimal places we want this to be in. I'm going to come back to decimal places just in a second. I might just go down to 1, 2, 3 decimals. But down here we can add, and you can actually also show both inches and metric if you want to in here. It might get a little cluttered. Down here we can show what kind of deviation we want on this one, and there's kind of like different ways. So on the outside here we might select the symmetrical one, and that let us put a dimension on the outside. So this here defaults to 10, but I'm going to do it 5. So what I have done right now is I have told you that the width of this box is 3 inches, but it can vary plus and minus 5 thousandths. And we will do the same thing on the rest of the dimensions. We will go in, we will add some kind of tolerance here on the outside. Let's just make it again 5. And we are telling you, or telling people who's got to make this part, that you better, this is what we're going to be measuring when you give us the part and say that it's done. I am going to make sure that the part is within these tolerances, so you can figure out if you should show up with a chainsaw or maybe some tool that is a little bit more accurate than that. I hope that kind of makes sense. That is kind of like tolerances. We're adding these in here. Now let's talk about the clearance in here, because I would actually also specify that, right? Because it's going to be a dimension on the inside for our lid here. So let's place that dimension. So there we got that dimension there. Now again, this has to be this has to have a tolerance on it. You can't come and tell me with a drawing like this that you just want a 2.5. I need to know that there is a range. Now many times on this type of drawings, you will find notes that can appear different places. So what you might find is a note that looks somewhat like this. Open up a note here. I'm just going to do it out here for right now. And you might find a note in here. It's going to jump on me a little bit. Bear with me. That looks somewhat like this. Let's make it 0.100 maybe. And that note will normally actually be inside of this box, right? You might find a note on a drawing that says, this is the tolerances. If unless otherwise is specified, if there's a 2-place decimal, it's plus or minus 10. If there's a 3-place decimal, it's plus or minus 5. And if there's a 4-place decimal, it's plus or minus 1 thou, unless otherwise specified. What that means is that if we go over and look at this decimal places right now, there's 4 decimal places. Or let's go over and look at the lid, what we're talking about. So this one here has 4 decimal places right now, what tells me that it has to be within 1,000ths, what is really a tight tolerance, especially in wood. You would never do it in wood, but in metal you would do it plus or minus 1,000ths. But for this lid, I might actually, because I know there's another part that's going to fit in there, I might actually do specify my other tolerance in here. So I'm going to go in here and I'm going to go back into 3, what is fine, because I'm going to specify my own tolerance. Now, instead of a symmetrical this time, like we just did before, I'm going to go to a deviation. That will actually let me go to a plus and minus. So for this opening, I might specify that you can go plus 5, but minus nothing. That tells me that the box right now can go, it could actually be 2.505, but it could not be 2.499, right? And then down on the lid, down here, let's do another dimension. We might specify on this one, open that one up. I'm going to go 3 just to make it a little cleaner. Down here, we might specify that this one is going to be on the upper, it has to be 0, but on the minus side, it can be 0.005. So right now, this one can never be higher than 0.25, but it could be 0.2495, and it will still be in tolerance. So that is how you normally will do the clearance. Now, in this case, here, there's a couple of things you should keep in mind. One is that the overall between the two could actually be 10,000ths, because one, the pocket could be as big as it could be, or it would be 2.505, and you could make the lid 2.495, or when you leave 10 thousandths, what would actually be a pretty sloppy thing, but it could also be at the minimum here, where we would say no, we can't, it would be 0, 0. And that would not work, as I said earlier. Trying to fit two things together that is not in the same, that has the same size, that is not good. So we would actually probably go into one of these and say, you know what, it has to be -2, and then maybe just to open up the tolerance a little bit, then we might go to 7, just to make sure that you have 5 thousandths. And now we at least will guarantee right now that the two parts would fit together, because there is now a clearance in there. But we're also noticing that we have a pretty big gap, because now this one really be low, this one really be high. I hope this is not too confusing. So to add to all of this, because this suddenly becomes a little complicated, right? And think about if you had like multiple components that had to fit together. So this is what we call tolerance and stack up. It can be really complicated. What you sometimes will see happening on a part like this is that you will add a note to the thing in here that says slit fit. Okay? And now what I have really done is I maybe would not have any tolerances in here, but I would have a slip fit call out. And now we can start arguing about what is a slip fit. It would probably mean that the part can come in and out easily. And again, as a machinist, I would say I still need some tolerances. I can't just make things, without having tolerance. The last thing I'm gonna leave you with here, before I take a couple of the questions in the live stream, because as you see we have a bunch of people in here, all kinds of good comments in there. The last thing I want to show you is something else, I'm not trying to make this more confusing than it already is. I hope this is not too confusing. But there is also a couple of other questions you should ask. Another one would be, what kind of surface finish do you want this to be? Because I can actually make something within tolerance, but it has a very rough surface finish. So there's a symbol up here where you can add a surface texture to it. The other two symbols over here that you should just know about is that you can also say that there is a datum. What a datum means is that this is where I'm going to measure something from. So if I go in here and I place a datum in here, right there, this is now called datum A. What you also could see on a drawing is something called GD&T. And this is more complicated stuff. And I will say, anytime I used to quote work, if I had any work with GD&T on it, I definitely paid a lot more attention to these call-outs. But what you could do in here, just to show you what it is, I'm not trying to really have a lesson on it, but what I could do is I could say in here that I want a parallelism, that's what this symbol means, of a tolerance, and let's just do this what we did before, 0.005 to datum A. A. So what this means is datum A, the bottom of the box, is kind of like our ground level, and the top, this surface up here, the top of this box has to be parallel within 5 thousandths of this datum A. Okay? So, that was a half an hour. I hope this kind of makes sense. I hope that this was not too out there. It's a lot to take in, but so just to kind of like just to recap that. Normally you make your models too nominal, but then in your drawing is where you specify what clearances you want, any extra information you want to add in there, such as surface finish, and that kind of thing. Like I said, I'm probably going to call this video Volume 1 because I could definitely see we come back and talk about that. But most things, including when we talk about this part here, most things do need to have tolerances on it, right? Because like I said, somebody's going to show up to the party with a chainsaw. Somebody's going to show up to the party with a file, and they can get two different results and still say that they are within, they're 3 inches. Also, again, are you going to measure this with a tape measure, or are you going to measure this with a pair of calipers? All right, I'm going to take quickly and just look at in here and see what kind of questions we have, because we have over 80 people, which is absolutely awesome. Again, sorry about missing the sound in the beginning. I'm taking care on the YouTube video recording. I'm going to go in and fix this. Don't worry about it. So let me just scroll down here. Got people from Dubai. John asked a good question. Silly question. There's no silly questions. How do I spin the model around without moving my mouse? Yes, I think actually somebody answered it. Peter. I do have one of these devices. I'm debating doing a video on these. I will do a video at some point. I have a couple of different devices like these. Really, and you spin the model around on this device. They come in different price ranges, and that's why I want to do a video on it. I really only use the middle button that spins around. I don't use all the fancy custom settings. So I could probably get away with a cheaper model. I think they start out about $100. Some people love these. Some people hate them. I like mine. I can go without it. But I know other people who would never do CAD without them. It takes about a week to get used to them. A video. All right. So make a stream on GD&T, please. Yeah. So I could do something about it. I wouldn't put myself as being the biggest expert about GD&T. GD&T, again, if you just jumped in, that is when we start having these call-outs on our drawings that specify different things. And you can see here, if I just go into the GD&T menu again here, you have all different kinds of call-outs. It's a flatness, circle tree, surface finish. There's all kinds of things in here, and it's definitely there's people out there who are pretty much like that's all they do at bigger companies. It takes kind of like your drawings to the next level. Peter just had a good advice. Find a friend with a space mouse and test drive theirs. That's a really good one. So there is a lot. Yeah. So another thing, Finn just said something about standards. That's another thing that gets a little bit tricky with this whole thing when it comes to drawings and dimensions. I gotta tell the story. I grew up in Denmark. I became a mold maker in Denmark. I came to the United States when I was like 24 years old. And I quickly learned that the drawing views, how you flip the drawing views on a 2D drawing, are different between the two countries, or between United States and pretty much any metric, and that is confusing. I will say I like the American ways best because they actually just wrap the drawing around the sides. It's a lot easier. All right, guys. Really appreciate you guys taking the time to join the live stream. Again, I'm sorry about the no sound at the beginning. That was totally my fault. I hope no lag today. We didn't have any spammers today. That was good. This was live stream number 41. Thank you so much for taking the time to watch this. Monday's live stream is going to be probably an hour earlier. It's going to be 2 p.m. Eastern. I haven't figured out what I'm going to show yet. And next week is actually going to be a little bit hit and miss because I'm actually traveling also next week and have some vacations and things like that. We'll talk about that next week. Really appreciate you taking the time. Happy Friday to everyone. I'm going to do as I normally do. I'm going to end the broadcast here. So if you're watching the recording, thank you so much. Thumbs up or thumbs down, whatever you think. And for you guys who are watching the live stream, I really appreciate it. I'm going to jump in the live stream here and say hi to everybody and answer any questions I can. Thank you so much. Happy Friday. Have an awesome weekend.